All right, this is the review for the projectile test for physics. Okay, so this is going over our Are You Ready quiz logistically. So after a rock that is thrown straight up reaches the top of its path and is starting to fall back down, its acceleration is, so we have this lovely, ball going up, and then we have it coming back down. And the thought is this is a question about acceleration. So it says the acceleration is greater than when it is at the top of its path, or the acceleration is less than when it's at the top of the path, or the acceleration is the same. If you remember, we said when it was going up, it was a negative 10 meters per second squared. And then when it was coming down, it was a positive 10 meters per second squared. And that negative was really just a directional piece. So the answer to this question should be C. The acceleration is the same, regardless of whether it's going up, whether it's coming down, whether it's at the top. Acceleration is always the same. Question 2. In the absence of air resistance, the vertical component of a projectile's velocity doesn't change as the projectile moves. Well, we know on our t-chart that we write not dx's. In the y side of it, we write dy, voy, vfy, a, and t. Well, automatically we have two different velocities. And this statement is saying that the velocity doesn't change. Well, we have acceleration in the y-plane. So yes, the velocity does change. So that makes this statement never true. Okay? So velocity in the vertical is always changing because of acceleration. This question, though, is talking about the horizontal component of velocity, and this one is on the x side. We know we write dx, vx, and t. And depending on if it's an up-down problem, this t might be a capital T instead. But it's saying the horizontal component of the velocity, a projectile's velocity, doesn't change. Well, we only have one, so that makes complete sense. And there's no acceleration in the x-plane. So this would be a statement that is always true. The horizontal velocity of a projectile doesn't ever change because there's no acceleration in that plane. All right, at the instance a ball is thrown horizontally, another identical ball is dropped. Okay, key here is they're coming from the same height, and they ask you which ball hits the ground first. Well, neither they hit the ground at the same time. Hopefully you remember the visuals I showed you. We did a Mythbusters bullet fired as well as a cue ball that was dropped and shot, and we saw how they all landed at the same time. So if they come from the same height, they're going to hit the ground at the same time. And that's because of the formula T equals the square root of 2 dy divided by a. They have the same acceleration, they have the same dy, so their time in the air is the same. A ball is thrown into the air at some angle. Okay, so it's going to go all the way over here. All right, at the very top of the ball's path, which is right here, okay, its velocity is. Okay, so our thought is when the ball is right here, we want to say, okay, is it entirely vertical? Is it entirely horizontal? Is it horizontal and vertical? Well, remember when we're going up and then when we're coming down. At this location, the velocity in the y is 0. But the velocity in the x has stayed the same because it was the same as it was down here. So that value's a Vx value. So at the very top, this is entirely horizontal because the vertical velocity's gone away. Now if I was talking about it over here, it would still have the Vx, but now it would have a Vy. And then if I was talking about it here, it'd have a Vx, but it'd have a bigger Vy. So again, so that Vy changes. So it's entirely horizontal, though, at the top, at the very top. A ball is thrown upwards with a speed of 30 meters per second. So we're going to say 30 meters per second right here. At the same time that a ball is thrown downwards at 30 meters per second. Okay, notice they're thrown from the same height. Which of the following quantities is true? Well, this ball has to go up and then it has to come back down. This ball would just come back down. Okay, so the time in flight. Well, no, those aren't the same because of the fact that the one that's thrown up has to go up and then come back down before it falls all the way down. So it's in the air a lot longer. Landing velocity. Well, right here, this ball has a speed of 30 meters per second again. So they have the same distance to cover. So yes, their landing velocity would be the same. Both of these are projectiles, so gravity is acting on both of them. So yes, their acceleration is the same. Total distance traveled? Nah, because the one that's thrown up has to go more distance before it can finish going all the way down, whereas the one that's just thrown downwards just goes downwards. Now, if this question had said total displacement, then the answer would be yes, but just total distance, no. All right, now this is a workout problem, so we have to think about these. You are going to have a problem like this on your test. So I have, oh, and there's the bell for the end of the day. 24 meters per second at an angle of 34 degrees. Okay, so then I need to look at my Vx and my Vy. And everybody should be able to calculate those. This first one asks me for my Vx, and to calculate my Vx, since it's an adjacent side, I would do the cosine of 34 degrees multiplied by 24 meters per second. And then for the Vy, since it's the opposite side, I would do sine of 34 degrees times 24 meters per second. Okay? Alright, so this is the same question, and we just solved the information previously. So now you can make your XYT chart. And on the x side, you'd have dx, vx, and capital T, because this is an up-down problem, which we should know is just 2 times little t. And then we just calculated, if you did that calculation in the previous screen, I believe this is 1990 meters per second. Then on the y side, we have dy, voy, vfy, a, and little t. Okay, I'm going to go ahead and say that I want to talk about the down part of this, which will make my VOY 0. If you do it this way, then all of your VOYs in all of your projectile types of problems will be 0. Hopefully everybody just heard me say that. All the VOYs will be 0. Then when we calculated this, I believe this was 13 point... Alright, so when you did the cosine value, or the sine value, you should have gotten 13.42 meters per second. And we know our acceleration is 10 meters per second squared. So they ask us to find the time, and to find the time, you're actually going to use your y information to do that. So you're going to do your VFY minus your VOY over A. Okay? So then you would do your 13.42 minus your 0 divided by your 10. That would give you 1.34 seconds. But that's just the time down. So we'll need to multiply this times 2 because this total time that they're actually looking for is our big T. So that will actually be your answer here will be 2.68 seconds. And that will be your big T. Now, the next part is asking me to find my dx. Well, there's only one formula we can use in the x-plane, and that's vx times t. This one happens to be that we use the capital T because it is an up-down problem. So we'll use our 19.90 from our calculator multiplied by our 2.68, which we just found, and that will give us an answer of 53.41. And that's meters downrange. Okay? And then what's the maximum altitude reached by the football? Now, altitude is going to be back in our y information. You can use two equations. I really like to use this one because of the fact that I already have all these values, so I could just use it, and I know that manipulation. Most of y'all, though, are going to want to use this formula, which is your dy equals your voyt plus 1/2 at squared, which is completely fine, too. Either one of those, as long as you do it correctly, will give you the right answer. So if I go up and I grab my 13.42 number and I square it and I divide it by 20, then that gives me 9.01. Okay, so the answer here should be 9.01 meters. And you can double check that. You can do it in the other way as well, because we could go back up and find our time, which, remember, our time in the y was 1.34 seconds. So I could go back and find that in my calculator, and I could square it and then multiply it by 10 and then divide it by 2, and that gives me the exact same answer. So it doesn't matter which equation you do, you're going to get the same answer. All right? Hopefully this helps some, and then hopefully you guys are ready for your test.